Let us look at a line integration problem. I'm going to look at solving it using direct line integration and then using Green's theorem, because I want to get the answer from line integration to make sure that when I get the answer from Green's theorem, it is the same thing. Now, it says you must evaluate the integral along a curve around a closed path of x squared plus y squared dx. dx means changing horizontally, so it is this. So this is the horizontal component of vector plus 2xy dy. So this is a change in the vertical direction. So this is a vertical component of the vectors. And of course, this is the equation of the vector field. Now, here, dx, dy, right, everything is okay here. I was looking to see if anything is missing. Now, around the boundary of, I had seen this on an exam paper. The way they write the region is this. It's a set based on what I see here. It says x comma y colon means is such that. That's what the colon mean, or they could use a vertical line as well. Such that this is what you see next. X is greater than or equal to 0 and less than or equal to 1, comma, then it says y is greater than or equal to 2x squared and less than or equal to 2x. You close the bracket. That's what it means. Now, they gave this boundary in a tricky way, right? We can't figure out what it is, what it looks like. If you have your x-axis and you have your y-axis. Now, what this thing is suggesting is that you have a line between, where x is between 0 and 1. So it goes from 0 on the x-axis to 1 on that x-axis. Now, as for y, what you're going to have here is that y, you have a curve as having the equation y is equal to 2x squared, and another curve that says y is equal to 2x. So you have two equations here. Now, you're expected to know what these equations look like. You know that y equals x would be a straight line looking like this. Y equals 2x would be steeper because the gradient of this is 1, the gradient of this is 2. Alright? So you have the line y equals 2x. Now, let me move this one a little closer. Okay. Y equals 2x. And then y equals 2x squared. You're expected to know that the basic equation of y equals x squared looks like this. So y equals 2x squared would be steeper, right? It's a bit steeper. So y equals 2x squared Look like this, right? Now notice it says y is greater than 2x squared, but less than x. So they're talking about this region here that is enclosed. Let me label it R. That is enclosed region. Alright? So you have this outer part, that's y equals 2x squared, and this other side is y equals x. Alright? So there you have the region. Now, here, what we're going to do is for part A, we use direct line integration. Part B, later on, we will use Green's theorem. Alright? Now, what I'm going to, before that, let me just erase some of these things here. Alright, what I'm going to ask you to do is pause the video, write this down, and calculate where both intersect, both curves intersect. Alright? And then I want you to use both methods to do the calculation and ensure that both answers are the same. If the answers are different, then you made a mistake somewhere. Now, we'll look at this quiz, at the solution in the next video.